Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give you an example of hypothesis testing for the difference in population proportions. So here, according to a study by Hewitt Associates, the percentage of companies that hosted holiday parties was 67% in 2001 and 64% in 2002. So these two here are different groups. And so this is the result of the first group, which is P hat. This is the percentage, this is the proportion in 2001. And this is another value, which is P hat, the sample proportion or the sample percentage in 2002. Suppose that this study is based on samples of 1000. So this is the sample size for 2001 and this is the sample size for 2002. Test whether the percentages of companies that hosted holiday parties in 2001 and 2002 are different. So the keyword different here is representing this symbol obviously, and therefore this statement here clearly corresponds to the alternative hypothesis, and this is the value of alpha 1%. Alright, so now we're going to start with writing the null hypothesis and the alternative hypothesis. So we start off with the alternative hypothesis because this is what given here, and we're going to say that the percentage or the proportion here for 2001 is different, which means not equal to the percentage in 2002. And because of that, we know that our H null must be the proportion of 2001 is equal to the proportion of companies that hosted holiday parties in 2002. And again, I prefer to write down this hypothesis statement in terms of H null. It will be P for 2001 minus the proportion for 2002 equals to 0, and H1 is the proportion for 2001 minus the proportion of 2002 is not equal to 0. So that's the final look of my hypothesis statements. Next is calculate the test statistic, and since this is about percentage of companies or proportions, therefore what we're going to do is you can refer to this test statistic here. So this is the test statistic to test the difference in the population proportions provided that sample sizes are large, and so you can use the normal distribution as an approximation to the binomial distribution. And based on this test statistic, you know that you have to refer to the standard normal distribution table in order to find the p-value or the critical value. Okay, so these are the formulas. This is the test statistic. P bar here is given by this formula. Alright, let's go back to our example. This one. So here I'm just going to write down the formula, and again when you write down the formula you have to follow the convention given here, which is 2001 minus 2002. So therefore the sample proportion of 2001 minus the sample proportion of 2002, and accordingly you will have this one for 2001 minus for 2002 the proportion. This one is over P bar Q bar 1 over sample size for 2001 plus 1 over sample size for 2002. Okay. So I'm going to substitute the values. So here we have the percentage in 2001 is 0.67, X in 2002 is 0.64 minus this value here is going to be equal to 0. Okay, so I'm just going to substitute value into this. So how about P bar? According to the formula, P bar is equal to x1 plus x2 over n1 plus n2. So what is x1? x1 is the number of companies that hosted the holiday parties. So if you know the percentage of companies is 0.67, so this is the percentage, 0.67, that comes from 1000 companies. Therefore, the numbers, which is the number of companies in 2001, is going to be 0.67 times 100, and this is equal to 670. Okay, so this one is 670 plus x2 here represents the number of companies that hosted holiday parties in 2002. So this is the percentage of the companies in 2002. Therefore, x for 2002 is going to be 0.64 times 1200, and the answer here is 768. So this is the number of companies that hosted holiday parties in 2002. So that is 768 over sample size for 2001 is 1000, and sample size for 2002 is 1200, and based on this you will be able to get the value of P bar. So the value of P bar is going to be 0.6536. so you can try punching these numbers into the calculator. You will get the result is 0.6536, and once you get P bar, you will be able to get Q bar. Q bar is just 1 minus this value. So 1 minus 0.6536 is 0.3464. Okay, so that is the value of Q bar. And then here we have 1 over sample size is 1000 plus 1 over 1200. Okay, and based on this, you will be able to get the test statistic is 1.47. So that's the test statistic. Okay, so the third step is to come up with the critical region and the critical values. So this is the third step. Just going to sketch the critical regions, and this is the standard normal. The middle point is 0, and since the alternative hypothesis here is clearly a two-sided hypothesis, therefore the critical region will be on both sides, which is on the left side and also on the right side. So you have two critical regions because you have a two-sided hypothesis statement. And the area for these two is going to be 1% divided by 2. So the area is going to be 0.005 each. 0.005. Okay, and based on this, I'm sure you'll be able to find the critical value. Critical value is this value here, such that the area to the left is 0.005, and another critical value is this one, such that the area to the right here is 0.005, and these critical values are on the horizontal axis. And I believe you will be able to get the critical value on your own, so I'm not going to demonstrate in detail, but I'm just going to write down what are the critical values. So this one is 2.58, and this is a negative value, 2.58. And if you want to write down, you can write down critical value as plus minus 2.58. Okay, so now the fourth step is to decide whether the null hypothesis should be rejected or not, and that will be done based on comparing the test statistic with the critical value. So 1.47 here is situated somewhere here, so this could be 1.47. Okay, and clearly this doesn't fall into the critical region. So these are the critical regions here, and we can say that the test statistic (1.47) doesn't fall into the critical region. Therefore, H null cannot be rejected. Okay. Right, next we are going to conclude. And as I said earlier, whenever you want to conclude, you will always relate your conclusion with the alternative statement. And if you look at the example here, the alternative statement corresponds to this sentence here, where you can actually use this sentence whenever you write your conclusion. So here I'm going to say that there is not enough evidence to say that the percentages of companies that hosted holiday parties in 2001 and 2002 are different. Alright, so you can fill in the blanks here with this exact sentence here. So there is not enough evidence to say that the percentages of companies that hosted holiday parties in 2001 and 2002 are different. That's it. Okay, thank you very much for watching.